Alrighty now, and thanks for joining the Math So Easy team. And as you can see today, our focus is on how do you scale up a ratio. Okay, there's that famous word again, ratio, which we know all a ratio is a comparison of two quantities. So in English, that means that we're going to take two things, I don't know what they're going to be right now, let's call them apples and oranges, and we're going to compare their quantities. Quantity meaning how many are there. So we are going to look at two or more things and we are going to compare them by their quantities, just how many are there of each. And that's all a ratio is. Okay? And remember, this is a little bit more of the intro stuff that we need to understand our proportional reasoning. That's what we're aiming for, okay? But a lot of kids say, oh, I don't like proportions. I don't want to do the proportion way. And that's because somewhere along the line you missed the basics. So finding ratios and scaling them up is an introduction to that. All right, so let's jump right into it. Okay, so if we look at this here, we have a question. It says, what is the ratio of stars to smiley faces? Now look, in that little curved cornered rectangle, that's a set. All right, now it's a set. And there's two things in the set. We have stars and we have smiley faces, okay? So those are both of the parts of the set. Stars, that's a part, and smiley faces, that's a part. It's the only two different things there. And those two parts make up the set, which is the whole. All right, so what is the ratio of stars to smiley faces? So they're asking us to compare, remember that word ratio, it means to compare the quantities of the stars and the smiley faces. All right, so first plan of action, the first step in the plan of action is to figure out the ratio. So we know, once again, the ratio, we're just comparing the two parts you have there, the stars and smiley faces. We're going to compare their quantities. So how many of each are there? Well, if we count the stars, we see we have 1, 2, 3, 4 stars. And if we count the smiley faces, we see that we only have 1. Simple. First step is done. So I'll put a reminder over here that I have 4 stars and 1 smiley face. Now, the ratio of stars to smiley faces is what? Okay, this is where we have to start to be careful. We have to look back at the question and look for the order that the parts are mentioned in. What did they say first? Now, I'm going to read from the ratio. It says the ratio of stars to smiley faces is blank. So they mention stars first and smiley faces second. So when we write our ratio and our different representations, we have to make sure that the 4 comes first, smiley face comes second, and fraction form, the 4 should be on top because it was mentioned first. So your answer should have been 4:1. 4:1, 4/1, or for every 4 stars there's 1 smiley face. Now, why is the 4 first? Once again, why isn't it 1, 2, 4? Because in the question they asked you what is the ratio of stars to smiley faces. They mentioned stars first, so you put stars first. And for the fraction form, you make sure that 4 is in the numerator and 1 is in the denominator because there's only 1 smiley face. And in word form, you could also say in an order, for every 4 stars, there's 1 smiley face. All right, now, what does it mean to scale up a ratio? Okay, to scale up a ratio means to add pretty much another set of the original ratio. So right here, we have this set. We have these two parts, these stars, and this smiley face that make up that set. Now, in that set, we know the ratio is 4 stars to 1 smiley face. So if we want to scale it up, that means we pretty much want to double it, or I don't like to say double because we could scale up to infinity, but let's just add in another set of the same original ratio. There we go. Now, so for every 4 stars, there's 1 smiley face. So every time I add 4 stars, I have to add a smiley face with it. That's the original ratio. So now this ratio, which was originally 4:1, has been scaled up to 2. Boom! Another set. So now it's scaled up to 3. But look, I kept the ratio consistent. for every 4 stars, there is 1 smiley face. So now, basically, we have a new ratio. And I'll give you a few seconds to count it. And remember, we're looking for the ratio of stars to smiley faces. So be careful of what you list first when you're writing your ratio. And your answer should have been 12 to 3, 12:3, 12 over 3, or for every 12 stars, there are 3 smiley faces. You have scaled this ratio up to 3 times. All right, let's go for another example. Here we go. What is the ratio of microphones to iPhones? So I'll give you a few moments to count up. And I know my answer is 5 over 2. Why is the 5 on top? Because whatever they mention first in the question, we put that quantity in the numerator when we're using the fraction form. And the second part that they mentioned, which was the iPhones, we put that quantity in the denominator. Now, if you use 5 to 2, 5:2, or for every 5 microphones, there's 2 iPhones, that's correct also. I just chose to use the fraction form. Okay, let's scale this ratio up 4 times. Now, although it may look different, this is the same ratio as the previous slide. I just chose to put all the microphones together and the iPhones together so it looks easier, or it's better to look. It's a better look, I guess I should say, when it's scaled up, when everything's together. All right, so for every 5 microphones, there's 2 iPhones. So let's scale it up to 2. Whoa. For every 5 microphones, there's 2 iPhones. Let's scale it up again. Whoa. For every 5 microphones, there's 2 iPhones. Now, I'm going to scale it up 4 times. So how many microphones do you think I'm going to put? 5, and I'm going to put 2 iPhones. Why? Because we're just adding extra sets of the original ratio. It was 5 to 2. So every time we add a set, we have to keep it 5 to 2. And now we have a new ratio. And that ratio is, I'll give you a few moments to count, and you should have got 20:8, or 22:8, or 20 over 8, or for every 20 microphones, there are 2 iPhones. Remember, any representation is correct unless they specify which one they want. All right, so you have now scaled up an original ratio. Okay, so that kind of caps off what we're going to do for today. But we're going to do future lessons on this because I want you to understand the power of knowing your multiples. Once you know how to find a multiple of any number, then when you're doing things like this, you kind of won't have to draw out the scale up using symbols or whatever you want to use. Once you know your multiples, you'll be able to look at a problem and know that the original ratio has been scaled up whatever amount of times, that it has been just by looking at the numbers. But that comes with the power of knowing your multiples, which heads back to the multiplication times tables, as I tell you, children. But we will get there. Thanks for joining Math So Easy, and we're gone. See you next time.